Hi, my name is Keita Ohshiro. I'm a PhD student at the New Jersey Institute of Technology in the United States. I'm presenting the work with Mark Cartwright, my PhD advisor. Our work is entitled Audio Engineering by People Who Are Deaf and Hard of Hearing, Balancing Confidence and Limitations. I'll be presenting our interview study with 8 deaf and hard of hearing audio engineers in the music field to understand the current state of accessibility. I will first describe the motivation behind the work. Then I'll provide background information on the term DHH, referring to individuals who are deaf with a lowercase d, deaf with an uppercase d, and hard of hearing. I'll also briefly explain audio engineering. Following that, I'll share the research methodology, findings, and discussion. So, motivation. It is often said that audio engineering has become democratized thanks to the development of technology. Historically, audio engineering was primarily for professionals who had access to high-end hardware and software. However, with technological advancements, it has become more affordable and accessible to a broader audience. Now, many individuals engage in audio engineering at home using their personal computers. However, there has been limited research on the accessibility of audio engineering for people with disabilities, particularly for DHH people. The DHH population continues to grow. The World Health Organization reports that over 1.5 billion people globally, or 1 in 5 individuals, experienced some degree of hearing loss as of 2021. This figure is expected to increase to nearly 2.5 billion, or 1 in 4 individuals by 2050. Additionally, in the field of audio engineering, noise-induced hearing loss is an occupational hazard as it often involves exposure to harmful noise levels. But the stigma within the industry prevents open discussion about this issue. Considering this context and the fact that audio engineering is predominantly auditory, we believe it is important to develop a comprehensive understanding of the current state of accessibility in audio engineering for DHH individuals. Before we dive into our research, let me first provide some background information. The term DHH refers to individuals who are deaf with a lowercase d, deaf with an uppercase d, and hard of hearing. The difference between deaf with a lowercase d and deaf with an uppercase d is explained from a social and cultural view. Individuals who identify with the uppercase deaf have a strong sense of belonging to the deaf community. They often share a common language, such as American Sign Language. Terms such as hearing loss might be considered negative or impolite because they suggest deafness is a deficiency. The difference between lowercase deaf and hard of hearing is often based on audiological criteria. Typically, individuals with a milder degree of hearing loss may identify as hard of hearing, while those with a more significant degree of hearing loss might identify as deaf. Here are some of the common hearing experiences among DHH people. First, they tend to find it difficult to hear certain sound characteristics, such as pitch, loudness, and spatial information. Moreover, they may encounter difficulties in specific situations and environments, such as hearing in noisy restaurants. Additionally, issues like tinnitus, hearing fatigue, and hearing fluctuations can further impact their hearing. Some DHH individuals utilize hearing devices, such as hearing aids and cochlear implants, to enhance sound perception through their ears. While these devices are often helpful for speech perception, they can complicate music perception, which involves a wider frequency range and elements such as melody and harmony. In addition to auditory hearing, some hear sound through vision and touch. Audio engineering is an act of reproducing and modifying sound. It includes several key steps: recording, editing, mixing, and mastering. Throughout these steps, the goal is to create the best sounding product. People use audio production software known as digital audio workstations, or DAWs. DAWs provides basic features to conduct audio engineering, which can be expanded by installing additional plugins. Using DAWs, the audio engineers modify each of the sound recordings or tracks to make everything sound good as a whole. It's important to note that audio engineering isn't merely a procedure, it's a form of art. It involves a lot of decision-making based on an understanding of sound and subjective choices to achieve artistic goals. So, methods. To understand the current state of accessibility in audio engineering, we conducted remote semi-structured interviews with 8 DHH audio engineers. Each interview was about 1 hour, and participants were compensated a US $20 Amazon gift card or equivalent in their country of residence. During the interviews, we began asking participants for demographic and hearing-related information. Then we asked about their experiences in audio engineering, such as how they started audio engineering, current practices, challenges, and workarounds. Additionally, we asked participants to show us their past work and guide us through the processes by sharing their screens. For analysis, we employed Brown and Clark's reflexive thematic analysis. Our participants identified as lowercase deaf, single-sided deaf, hard of hearing, and single-sided hard of hearing. 3 participants were born DHH or became DHH early in life, while 5 became DHH later in life after gaining knowledge in audio engineering or related to musical fields. All participants were well experienced in audio engineering as professionals or advanced amateurs. It's important to note that our study did not include any capital D deaf participants or beginners, and all participants were male, which represent one of the limitations. Findings. Through the interviews, we identified that participants navigate through audio engineering while balancing their confidence and limitations. We organized our findings into 4 sub-themes: hearing challenges in audio engineering, technological workarounds and techniques, social-based workarounds, working with hearing peers, and learning and growing audio engineering skills. I'll now share some of the main findings. Regarding the first theme, hearing challenges in audio engineering, we observed underlying insecurities regarding participants' auditory perceptions in audio engineering due to their hearing status. One participant expressed, "My ears are a little deceptive." Additionally, those who were born DHH mentioned a lack of innate understanding of sound compared to hearing individuals. For instance, a participant born single-sided deaf remarked, "I can't ever really experience stereo sound the same way that people with 2 ears can." These insecurities often translated into extra time and effort to complete audio engineering tasks. Another participant noted, "If I did not have the hearing loss, it would have taken half the time at least because I could trust what I was hearing." To address these challenges, our participants employed various workarounds, which brings us to the second theme, technological workarounds and techniques. Participants utilized visualization and manipulation of sound using those to accomplish various audio engineering tasks, such as volume adjustment, equalization, stereo imaging, and applying effects. This is an example of sound manipulation. A participant with mid-frequency loss used equalization to boost the mid-range frequencies, making it easier for him to hear that range during the mixing process. Here's another example of sound visualization. This participant, who is single-sided deaf, used visualization to better understand the stereo image of the mix, such as how sounds come from left and right channels and how they interfere each other. The workaround reduced the listening workload, enhanced their confidence in sound perception, and improved task efficiency. However, our participants still face challenges due to the limitation of technological solutions. Simply put, visualizations and manipulations of sound could not fully convey the sound. As a consequence, participants still felt a lack of confidence in audio engineering. A participant said, "I can depend on my eyes and the graphic readouts only so much." Another participant said, "You do end up with complicated guessing game when you are mixing songs." This limitation leads to the third theme, incorporating hearing peers support. All participants reported seeking support from hearing individuals to address their lack of confidence and validate their quality of work. One participant expressed, "To make sure that I haven't done anything that sounds off balance or anything that's probably a result of my hearing, because I'm afraid that there will be something that I will mix that I will sound bad and I won't notice." It's important to note that seeking feedback itself is common in audio engineering, even for hearing audio engineers. However, we observed that participants rely more heavily on this feedback to compensate for their lack of confidence and ensure the quality of their work. Another participant shared, I feel like now I'm more reliant on that feedback, whereas in the past, I would be confident enough to put something out or give clients like a final mix without necessarily having somebody else check it. I wouldn't do that anymore. While hearing individual support was beneficial, its reliance introduced additional layers of considerations to navigate. One significant challenge was the mental burden of constantly seeking assistance. Participants often relied on close friends, colleagues, or partners for help. However, as this assistance was often rooted in kindness and friendship, they felt reluctant to overburden others and were uncomfortable asking for help too frequently. In addition, we also observed participants' desire for independence, seeking to assert their capabilities as DHH audio engineers and expressing reluctance to seek support. The last theme is about learning and growth in audio engineering for DHH individuals. First, participants emphasized the importance of understanding and accepting their hearing limitations. They needed to assess which tasks they could handle based on their hearing and audio engineering skills and determine appropriate workarounds. One participant stated, the challenge I had to face is to understand what my limitations were and stop. Don't go any further than that. Second, we observed participants leveraging the skills and knowledge they had acquired in audio engineering in the past. For instance, one participant mentioned that his tools and equipment remained unchanged after becoming DHH. He stated, rather than using different equipment, I rely on my experience and the skills that I developed before hearing loss. We also observed the extra effort to learn audio engineering compared to the hearing peers. One participant said, it was more important for me to understand what's happening acoustically and physically than the other students, because the other students can use their natural sense of hearing. Lastly, some participants expressed a feeling of disconnection from interacting with other DHH audio engineers and musicians. Given that the field is predominantly dominated by hearing individuals, they found it challenging to connect with their DHH peers. Some even did not think about seeking out such communities, yet expressed a positive feeling if there were such opportunities. One participant said, I've never thought of interacting with other DHH individuals in the field. I always thought that it's a very niche thing to be that age I'm with the disability I have in the field that I am in. But if there's other people, I'd certainly be open to it. I've covered the findings from the fourth theme, hearing challenges in audio engineering, leveraging technologies and techniques, incorporating hearing peer support, and leveraging growing audio engineering skills. Through these findings, we identified that participants navigate the field of audio engineering while balancing their confidence and limitations. Discussions. Moving forward, we see opportunities in designing tools to empower DHH individuals to confidently and efficiently conduct audio engineering while managing their hearing energy. Automation of audio engineering is one of them. There are commercially available automated audio engineering tools emerging like Lambda or ROX that automate the mixing and mastering process, but these technologies are not primarily designed for DHH people. We see the potential for research into modern technology with accessibility features, such as developing interfaces usable for DHH individuals and assessing how these tools impact users' creativity. Second, we suggest that approach to accessible audio engineering driven by the DHH community. In the accessibility and design field, we observe a shift from designing for people to designing with people to designing by people. Audio engineering for DHH individuals encompasses a broad spectrum of factors, such as DHH identity, degree of hearing loss, audio engineering tasks, technologies, skills, and knowledge. Designing by DHH individuals will help address complex individual needs. In future work, we plan to collaborate with DHH audio engineers, further investigate their practices and challenges, and collaboratively design solutions. Thank you very much for listening. Please feel free to reach out to us if you have any questions or if you are looking for any collaborations.